Magick Academy week 6. I'm on the road. I'm at a coffee shop right now. Our team is at Google I/O. Luckily, we've just had our NDA lifted, so we can actually talk about some of the work that we're doing with new Google language models. And that'll probably be next week, because we're going to have to push that to the cloud and enable the plugin that we've been working on so that you can use it. But yeah, you'll have another alternative to OpenAI in the new Google models, which are actually really great and exciting. And they have a lot of interesting features, like spreadsheet generation and specific code generation models and things. But today, I'm taking a little bit of time out before our usual time to pre-record this, because I want to go over some really interesting things that we're working on. So I'm gonna do a little bit of high level of what we're doing here, and then we're gonna talk about some of the specifics that you can apply today. Where we're going with everything is autonomous agents. We've talked about autonomous agents in some of the last sessions. An autonomous agent is autonomous. Well, let's talk about an agent. It expresses agency. It does things itself. And autonomous. That's the itself part. It has agency, and it has its own agency. Obviously, this is a new, interesting field, AGI, autonomous agents, and there's some clearly obvious problems with it. Like, what happens if the autonomous agent goes off the rails? So we're working a lot on how to make a loop to generate better data, and also keep you in the loop while it's running to make sure that it's learning from you what you want and building trust with you so that it can become autonomous. It's kind of like a self-driving car. You got to drive that car. You got to train that data. You got to work with lots and lots of small systems. But over time, we get the data to eventually make the self-driving car truly self-driving. And also, instead of having all these little systems that kind of work together, it just becomes like one bigger system. So that's where we're going. This autonomous agent track, developing data, creating these reinforcement loops with human feedback so that we can make sure the data is good, and then feed it into our fine-tuning process later. That's where we're going with this stuff. But today we're going to talk about complexity. Autonomous agents are very complex. You'll notice here this is not that complex. This is actually not a whole lot more nodes, apparently, in this graph than our Discord graph, right? It might even be less. But that's because we're hiding a lot of the complexity inside of graphs. So this right here, this root graph, which we call ELIZA, is actually a graph of graphs. You can see we have the input and the event destructure here, and that goes out to a create task. What is this create task? Let's open it. You can see here the create task is here, and there's actually a graph within the graph. There's a subgraph of this graph right here. This create task graph is this single node. This is a spell node. Spells and graphs are the same. Spells are sort of a way of expressing a type of graph. And you can see that instead of having all this massive ton, all those nodes out here doing this thing, which is actually honestly how it started, as it was last week, we've taken all that and wrapped it into a single node and created a module. Now, this has two ramifications. One, it makes it much simpler to look at this and see at a high level what's going on. And two, it means we can isolate individual parts of the functionality of this thing, and we can work on them separately. And let's say you work on we have a reasoning graph, right? It's not too complex. We have this reasoning graph, and you're like, you know what, that's actually not a great reasoning graph. I think I can make a better prompt. I can go in here and make a better prompt. I think I could do a lot more with this than what Moon's already done with this kind of base ELIZA model. So you work on that reasoning graph, and then you could send me your improved version of this graph. And instead of having to go and look at it and carefully, painstakingly rewire all of these into my graph, I could just go over here and say, cool, well, I'll just import your new one, and then I'll just switch it for that one. I'll just say, well, I'll go grab the, bam, grab the new one. Okay, great. And now I've got your new graph. And actually, something we're working on and trying to figure out right now is how can we let users share their graphs? Because if we could share graphs, we could start to make skills, and we could start to share skills. And instead of having just your agent does one thing, it might be able to do 50,000 things, because we have a community that's building and contributing and helping each other. And once we have enough graphs, we can even have it generate new graphs. So this agent right here has a lot of nodes in it, but they're embedded within the create task kind of subspell. And a subgraph, subspell, graph, we're kind of using these interchangeably. Spell and graph are sort of, in our nomenclature are interchangeable. So, I have this create task, which creates a new task for the agent to run. And that's kind of the essence of autonomy, is that it, creates tasks and executes them for himself. I have a reasoning module, or subgraph. I have a find skill subgraph. So once it's reasoned, it's like, well, what skill would I use? I need to search the internet, or I need to send an email, or I need to just plan out what I'm going to do. Those are all kind of skills. We have the actual, once we found the skill, we can just run it. This could all be another subgraph too, maybe, but we don't, it's only 2 nodes, so it's fine to put it here. So you can see we run the skill. We compose the object back together, and then we have another subgraph called reflection. And so reflection can be like, well, how did you do on that skill? So inside of each of these might be a whole, you can see a little algorithm here to, pipeline to move data through and come up with an answer. But we can look high level and just say, okay, cool. I know that this is my main input when my user types. And I know this is my task loop. And my task loop is pretty simple. It's reasoning, figure out the skill, run the skill, reflect on it, save the step, run until it's complete. So we're going to be talking about, I want to get into, we're definitely going to get into all of this, all of ELIZA. But what I really want to talk about today are subgraphs, and give you an idea of how to use those. Because it's a very, very powerful way to isolate your work, experiment with your work. You can make 2 versions of something and A/B test them. It's very, very useful abstraction. And I'd also and that will then kind of lead into skills. Skills are also a type of subgraph. However, subgraphs from the spell node are directly referenced. We select the spell here, and skills are actually loaded by name. So we can, if I go to we're probably going to make this a little bit stronger typed, because it can be a little buggy if you type a name wrong or something. It'd be nice if it was very, a drop down or a very we check it to make sure it's valid. It's called validation. But in the meantime, it pulls the spell in my name. If I go to I'll open spells. You can see I have a lot of spells here, but mainly I have a few types that I've made. I have modules. Modules are the subspells that I have inside of my main ELIZA graph that I showed you. I have skills, and skills are a type of graph. Let me just open the complete skill. And all it does is it takes whatever the current task is and it just completes it. Nothing too complex, it's just this complete task node. Tell the user I completed the task successfully, output that back to the main spell. So we have these skills. And so skills are loaded by name dynamically, that way we can have lots and lots of them. And subspells are loaded, they're referenced directly, and that way we can make sure that they're definitely not going to change, that this is definitely what I need to do right here is reasoning, for example, and that's more about embedding graphs within graphs to create this kind of super complex agents. So let's make a new, I have this one called spell parent, but there's nothing in it yet. I have a spell parent, and what I want to do is I want to make sure that my parent spell talks to a child spell, gets the output, and then brings it back to our playtest. So I'm going to make a spell node here, and I'm going to go down and I'm going to select spell child, which I've already made. You can see it opened up. What does spell child do? It takes an input, it responds with, I am being called from the child spell. Okay, cool. And it just sends that back to, respond is good. We'll talk about this in a second. We're actually going to just use a regular old output node. We'll talk about respond in a second, because that's going to be a very useful thing for you. So by default output will return back either to the parent spell, which this was called from, and it will return to the playtest, right? So the default output returns to the playtest. You could have a bunch of them, they return to the playtest. I'll save that. And then I can go back to my spell parent. Oh, I forgot to save it. So I have my spell child, I have my input. Let's go and let's make sure we make let's do this again. Spell child. And then we will put that into an output, right? So, save that. Input comes in, goes to the subspell, which is loaded, the spell child, goes over here, comes into this input, triggers that. Now we could have this output right here go to that, but we wanted to indicate that it's a little better than an echo node. It's actually, it should just write this. No matter what I say, it'll just export this, right? Then it comes back out of the spell child's outputs and goes into the output here. We're still working out a nice clean way to do outputs. But right now, for inner spell subspells, we use the default input and the default output. Now, you can also say add a public variable, like a text variable. Yeah, this text variable here, make it public, text, save it, and we go back to the parent. Well, I haven't actually tested this yet, so maybe it's working. But we'll also have our public variables exposed here. And I can, if I go and I refresh that, it's not seeming to be public yet, but that's something we'll be working on. So you will be able to expose public variables, and then those will be editable from your as node inputs. But primarily, you have one input into your subspell, and that just kind of unifies. Now, if you need, at this time, if you need some more input into here, you could compose an object. So I'll show you that in a second as well. So just to recap, your input comes in here, it goes into your subspell, it runs all the subspell stuff, and comes back out of the output, and then comes out to this output. And theoretically, if I type testing, you can see that it says, I am being called from the child spell. Great, that's all we wanted. An interesting thing is if I go here, you can actually also see that the green ran through here, so that the node updates are not just called in one spell, but also get propagated to the child spell. So the parent spell, you see it's green, and inside of here, you've got the green. This all ran this last kind of test. Great. So we have a couple of things to cover within that. How do we get more than one input in? Okay, well, let's talk about objects. So when I have a text variable, I just have some text. But I can actually make compound object, which could have multiple text things, for example. So we'll just do that. We'll say we're gonna go and we're gonna make two text variables. And we'll say this is text variable 1. Clone that. This is text variable 2. And now we're gonna have to get these into this one input. Tricky. Okay, take that output. We go down to the objects. We have this node called compose object. And you can see by default it doesn't have any inputs, but we can make some inputs. How about 1 and 2? Now these are not arbitrary names. These become the keys for this object. A key is like a way to access the value. And we call, objects are usually composed into keys and values. So what does that actually look like? Well, our data that we send into the input is also an object. And it looks like this. This is not really well typed, I'll just kind of clear it out. But you can see we have the sender is the key, and the value is user. Observer is the key, and assistant is the value. And let me just clean these up a bit so it makes a little bit of sense. And we have this kind of closing brace. And you can see we have key, value, and we have these braces here to indicate that this is an object. So this is some code stuff. You don't have to worry about it, but under the hood, this is what's happening. But visually, you have keys, and those are associated with values. Now the values are going to be whatever you assign, whatever you drag to that socket. So 1 will be here, and 2 will be here. Now we'll trigger that. Put these back. And now we're going to take the output of this compose and put it into our spell child. Cool. So we've composed these two into a single object that we can now do stuff with. Now you've already encountered objects a lot. You just probably didn't notice it. One place you've encountered it is in the event destructure, right? So what the destructure is it's the opposite. It's saying, hey, I've got some incoming event, which is an object type, and I'm going to break it out into all of the keys. And if I want the value of any of those keys, I just grab it and drag it off. So you've already used that. And on the opposite side, there's also an event restructure, which takes all of the keys and shoves it in. this is actually the exact same node functionally as this compose object. We've just typed it to make sure that the actual event data comes in here, right? As opposed to, because these are the actual keys for any event inside of our event system. So, you know, this is basically like a fixed sort of key value sort of input, whereas this is a dynamic key value input. You can make any kind of thing. So I could make this event destructure node here. I mean, I should probably make this bigger, huh? I can make this event destructure node here with this, or restructure, sorry, with this compose object. Cool. So I'll delete that. So I've composed this object, and I'm passing this object into this spell child. Now, we're not using the output here, right? We could, but we're, you know, well, let's say, actually, we'll say content, right? And so now we have to get the event, destructure it, and pass the content. We've done that a bunch of times. We'll do it again. So remember, the input is an event object. If you look in data, what's actually there is this stuff, sender, observer, type, client. And if I add a, because this is the data we're sending with our playtest when we send, right? If I add a event destructure here, a few of these are not represented here, like agent ID, but you can see sender, observer, there's sender, observer, client, channel, you got client, channel type right there. There's just a few that are kind of hidden from our playtest, like project ID is implied, agent ID is implied, raw data is implied, and embedding is null because we're not sending an embedding from here, etc., etc. So we send all this data in, it turns into an object that hits our input. Our input we then destructure to break out all of these. We grab the content, and the content is what you send into this playtest window down here, right, blah, blah, blah. We grab that content, we shove it into the content, and now we have this object that has 1, 2, and content. Cool. And I'll say, well, I gotta make sure that we trigger that so that it actually happens. And then I'll save that. Now if I go into my spell child, so I have this input coming in. I'm gonna delete that text. I don't need that anymore. So what's actually coming in here? So in our spell parent, you can see we have content, 2, 1. These are the key values. And so in here, we have to do the same thing. We have to get the values of content. Okay, so we have to get the same values. We have to destructure the values that came in from the parent back out into the child. So by default, what you're used to is, oh, okay, I go and I'm going to destructure the event, and then I can get all this data. But this is actually an input event, destructure, right? And what is input? Let me refresh really quick. What is input? Well, input is whatever comes from here. And you can see it fires. And that's going to contain all of this information. But this is actually not the information that's going to be provided from the parent spell. Because the parent spell is not an input in the same way. It's not an event input. It's, I mean, like a user input. It's sending data through this output right here, right? So we have to destructure or break out the values. And destructuring is like, it's basically, if you think of like structuring as building something, destructuring is like unbuilding something. It's like each brick in the building needs to get pulled out to be its own brick. That's a destructure. And it's a programming term. It's a sort of real world. So we want to take this output, which contains now 1, 2, and content, and break it back out into here. So I'm going to go down to our object, and instead of composing an object, I want to get values back out of the object. So this get values from object, this used to be called object destructure, but destructuring is kind of a confusing word. And I think it's very clear when I say, like, we have this object now. It's got the values of 1, 2, and content in it, and we want to break those back out. So my property names are going to correspond to when I compose the object. I'm going to decompose it, right? 1, 2, and content. Great. So now I have 1, 2, and content are the values that we've pulled back out of our subspell. So now I can fire those up. And now I have, I don't know, let's just add these together, right? Let's just make this all join. I'll say, make a text template. And this will be like from Subspell. And we'll say 1, 2, content, right? And we'll wire that up, and we need to do the same thing. We have to have some sockets on our template. 1, 2, content. Great, plug that in, plug that in. Now that should generate a prompt, and we'll return the prompt. So what would we be hoping to see from this is, well, we plug in some random text for 1 and 2, blah, blah, blah. We plug in whatever we type in our playtest becomes content. We join that all into a single prompt, and then we return it to our parent spell, right? Cool. So let's go back to our spell parent. I'm just exporting just in case something gets messed up. I need to use it. Go back to our spell parent. You can see we have variable 1 here, or 2, I guess, whatever. No, variable 1. We have variable 2. And then we have whatever comes from our destructure from our main input event, which is the content. Now, hopefully, moment of truth, hello there, you can see from Subspell, this is text variable 1, this is text variable 2, hello there. It ran the whole graph beautifully. And if I go back into my child, you can see it ran this graph as well. I don't know why sometimes it's not showing up green, that's a little weird, but it's definitely working, right? It definitely brought back all of the stuff. Now, if I go in here and I type, well, it actually worked okay. And the reason it didn't work the way we expected, but remember, content is a valid key of our event input. Remember, if I go back to my event destructure, there is a content output. So it got that. 1 and 2 were not defined. There is no 1 or 2 on this event that came in when I typed. And this is not coming from the parent spell, it's coming from me typing. So the actual information that comes into the input is totally different. So the information that is coming in is 1, 2, and content. This, I typed in something that didn't have any value for 1 or 2, and the net result was that 1 was undefined, didn't show up as anything. 2 was undefined, didn't show anything. But content did show up as something, and that's why it says agent from Subspell kind of missed 1 and 2, and then just placed in my content. I hope that kind of makes sense. So if I type in here, well, I don't get 1 and 2, but I could change my input data, and I could say 1 test and 2 another test. Save that. And then if I type, you can see it says test another test hello. Let's just say, like, even clearer, let's say 1, 2, because I've added those values to the input data that got sent into this when I'm typing. And remember, I'm in a spell child. So we're going to try and make this a little easier in the near future. The way that I do data tests and stuff, I use this little data thing, but this is kind of confusing and uses JSON, it's code, it's not super friendly. I just want you to kind of understand what's going on under the hood. You actually don't really need to worry about this too much. What you're really probably going to be doing is setting up your subspell, and then going into your spell parent or some sort of development parent spell you have, and running it from there so that you can see the data flow all the way through. So if I type in hello, you can see it gets text variable 1. Interesting, it deleted 2. Let me just make sure that's legit. 2, cool. This is text variable 2. You can see blah, blah, blah. This is text variable 1, this is text variable 2, blah, 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 blah. So usually when I'm developing child spells, I have some sort of parent spell that's got the setup of the data to test the child spell, and then I'm also referencing the child spell inside of, for example, ELIZA right here, where I have all these child spells, but I might also like have a development, like I have a couple of development spells, like here's a skill select, where like this is all set up to test the same thing that's in ELIZA, but I just need to make sure that I have it all kind of going, and so I can reference a subspell, from here for development with the right variables and data and stuff I need. I hope that kind of makes sense. Basically, spell parent composes some data, passes it to the spell child breaks out the data, does something with it, returns it, right? And this is a very powerful way to embed graphs within graphs. There's a couple of complex user experience sort of things that we have to think about here. The output that comes out of here is the default output. What if you wanted to make a subgraph that posted to Discord? Well, that would actually be pretty easy. You could just add another output here. keep the default output here. Oh, whoops. Keep the default output, and then we'll change this one to Discord. So now it's going to post to Discord, and then it's going to go to the default output. Now, you're going to have to do a couple of things here because one issue with the posting to Discord is you need to tell it what channel you would want, and so we'd have to probably figure out what channel and have a list of channels and stuff. So that's probably not what you want. What you probably want is just to respond to the user, no matter where they are. They're on Twitter, they're on whatever, and this actually makes your subspells really flexible because you don't have to really care. This isn't a Discord subspell. This is just a subspell. And what I want from this subspell is to respond to a user within it, right? So we have a new node in I/O called respond. And respond is similar to output. It calls very similar logic, but all it does is responds to the user wherever they sent the data from. So I go to outputs, trigger, and response. Now we're still working this out. This isn't really set up for the playtest window yet, but this is really, really effective for like sending something from Discord, for example. So I come through here, send to my subspell, and my subspell responds to the user, then outputs back to the parent spell, and the parent spell finishes. Now I could also have a respond here. I could say, well, okay, respond with the output here as well. And I can have responds in my root graph, and this is a big part of how we give feedback to the user in our autonomous agents is this respond node. But I can also bury it deep within my spell. As long as I pass the original event through, then it will know how to respond. It will know where it came from. And this event node gets passed in here, and well, we're probably going to need, for example, a event input. And that event input takes the original event, and now we pass that event into our spell child, right? So now our spell child is getting content and getting event from the root. And we can delete these, we don't need this anymore. On the other side, when I go into my spell child, I can, I'm just deleting my nodes, it's really strange. So we have a little bug we're gonna have to fix here after this session. I can grab the respond node here, and let me change my destructure a little bit. Instead of content 1.2, you saw I added that event, so we have content and event. Those are the things that are getting passed through now to here, right? Great, okay. Content, and in our text template, trash, man. So I don't know what's going on, it's deleting nodes, we're gonna have to work on that. A couple little bugs I'm working around. But let's say I have a text template, I'm making a new one, and this one will have event and content in it. Event, content. And then we will put that out. And now I can say like content and then event dot channel type. Right? Actually, I don't think I can destructure like that. I have to object, get value from object, and I'll get the value from event of, I don't know, channel type, which is just one of the values on an event, and I will pass instead of this event, I will actually name this channel type. So now I have a text template that takes content and channel type, like that, content and channel type, and then I need to go in here and I'll say content channel type. Save. Solid. Now the respond node, we do need the output to return if we want it. We don't actually have to return anything, but we do probably want to return stuff, right? So we'll do that. The respond node takes an event, and we have to pass that event down into the respond node so it knows where to respond to. Because right now it would just be responding to the parent. It would be responding to the actual spell parent would be the where it's trying to find the respond handler, and that's just not going to work. because you can't really respond to another graph. You want to respond to the event. So we grab the event that we passed in from the parent, plug it into the event override, and now this respond should work. The respond will work in the playtest, but right now it does not. It does work in Discord, and it's very useful for us to make sure that we're pulling information back into like our Discord. I'll show, I'll go through ELIZA a little bit to give you just a little bit of run through, but this is kind of what's happening through ELIZA is parent, child spell, lots of this create and pass objects around, respond, and output. So this subspell abstraction is very similar to our skills. Inside of ELIZA, I have a subspell for creating a task, and you can see that it goes through, gets the recent conversation, generates an objective for the conversation, passes that to the create task node, which creates a new task, and then responds to the user, hey, I just created a new task. And you can see the template here is I'm starting a new task with the following objective, right? It responds to the user here, and then it outputs that information back to our root graph so that we can actually get that task objective and pass it along. However, in ELIZA, we don't have to pass it along. We've created the task. Once a task is created, it goes into our task view here, and you can see some of the tasks that are running, and we have active tasks. Active tasks will actually run until they're no longer active. They can either be canceled because they ran into a loop and ran into a problem. They can be completed, which means that they happen more or less successfully, or they can be active, which means they're continuing to run. If I go to an agent that I have and I enable the agent task runner, then the task will start to run in the background. On a loop, all tasks will run on a loop until they're finished, as fast as they possibly can. So it can be a little overwhelming. You might you might want to come in here, make sure you don't have any active tasks when you're starting to develop. You might have to delete your active tasks, etc. But just so you know, it's creating tasks and it's dropping them on there in this subspell, and then responding to the user. This part basically, this is getting called at the same time, and this just stores the user's conversation input. The user said something to the agent, let's just store that. Once we get to the task queue, we are taking the task off the queue, we're running all the tasks, and then we're going to go and reason about this step in the task. Okay, well, I'm on step 2, what do I have to do in step 2? Well, step 1 was planning, and step 2 might be like going and checking my memory for any relevant kind of helpful stuff, right? So that's the reasoning loop, and you can look in here and you can see it's just a prompt that gets a bunch of information, makes a prompt. This is all a complex prompts template. You can see it's a template. You can see it's mostly just English with a little bit of bringing in the objective and the steps and stuff. And then we generate the objective, and then we return it. And so when we return this, not the objective, the reasoning for this step, we return the reasoning, you can see, well, the reasoning comes back out of this output. And then that reasoning goes into the find skill. So it's like, okay, well, I need to go check my email. What skill should I use for that? How about the check email skill? Okay, cool. And so this find skill gets the name of the skill. How does it do it? Well, we use a document search. If your skill is, hey, I need to check my email, and we have a similar skill for the user wants to check their email, they will have a very similar vector similarity, right? Their embeddings or their vectors are very similar between those two statements. And so we're going to go find the statement that is closest to what the user wanted or what the reasoning loop asked for, and then return that. That's a little bit abstract. So I have these documents here. These are just a few of the core skills, like plan, respond, cancel, and complete. And the plan skill, let me open that up, is ELIZA skill plan right here. And you can see, there's a whole, it breaks out the values, creates a template thing, actually generates the text for the plan, and then returns the plan. Yeah, that's pretty good. Okay, cool. So it took in reasoning. It decided, in this case, let's say it took in the reasoning, I should plan for this task. finds the skill plan, because the reasoning was I should plan for this task. And if we go to the document for plan, sorry, it's kind of hard to read here. Sorry, I have to cut this part probably because we can't show my notes. So the content for the plan description is I should write a detailed plan of what I want to do and the steps necessary to complete the task. Now, if the reasoning step is I should probably plan this task, of our available skills, that's probably the one that's going to be returned with the highest confidence, and so that's the one we're going to use. So the find skill identifies the document in our document store, which are all have embeddings and are searchable. You can see they have embeddings. Finds the one that's most relevant to the reasoning thought, which in this case would be like plan, pulls back the name of it, and then finds the spell that's associated with it. So obviously my spell is not called plan, it's called ELIZA skill plan, but that's because I have this ELIZA skill spell name. And so the find skill gets me the name of the spell, and then I'm actually just appending the rest of the name of the spell. So this spell name actually comes from this name right here, name plan. Cool. So I want ELIZA underscore skill underscore plan. I'm just a little bit of text magic. I'm sorry it's a little confusing, but basically find the document that most closely matches the story that I'm telling in my reasoning loop, bring that back, and get me the name of it, and then I will find the graph in my collection of graphs that fits that name, and I will use that as my skill. Cool. So then we find the skill, we run the skill, and this skill node is a subspell node. It's similar, but instead of directly referencing the subspell, we find it by name. We search for it. And so what are we searching for? Well, we are searching for the spell name. So it's going to call that. We're passing in the data from the task that we created. So it has reference to everything else in our task. And we're passing in the content, which in this case is actually the reasoning, right? The reasoning that came in is what we're going to pass into this skill. Then we get the output of the skill. Oh, I recall the user asked me what color my eyes were. I should, step one might be like, I should probably go look in my memory and see if they've asked me that before, and if I responded. I did. I found it using the find memory skill, and it returned that the user had told me their eyes were blue, and therefore the output of the skill would be, for example, I remembered that the user's eyes were blue. That then gets composed into this object, which has reasoning, the name of the skill, the result of the skill, and all the task data, and then we're going to reflect on it. And so this reflection is another submodule or subgraph that takes all that information and generates a prompt to say, well, how did I do? Did I do well? Did it fail, or was it successful? And also, what's kind of cool about this response is that it's in JSON. That's probably really complicated, but it responds with an object. In this case, you don't have to do this, but I did this. It responds with an object that has both what happened and also success or fail. And so was it successful or not successful? So that's what the reflection basically does. And that way later, on the next task step, we can say, well, the last step wasn't successful, so I either need to cancel the task or think about a better way to do it, right? And so we can kind of generally loop through this task until it's finished or canceled or whatever. It gets through this whole thing. It records a reflection, and then again returns the reflection back to the parent spell. And I remember I told you we have content of the reflection as well as success, truth or false, it was successful or not. And so we break those back out with another get values from object. Remember, we can pass an object in with a bunch of complex values to the subspell, and we can return an object and break it back out to its values, right? So we only need one input into our spell, but we can get a bunch of values back. And then we'll finish the task, which obviously takes the reasoning, the skill, the result, reflection. It takes everything and records a step in the task, right? And so a task has many, many steps, or maybe it has 2 steps or 1 step. And this will continue until we call the complete skill. So completing and canceling are also skills that we can call. And that's how we would cancel a task or complete the task. But once it finishes the task step, it gets put back onto the queue, and this starts all over until it's complete. So that's kind of how we're using all this stuff right now. I think that I'm trying to think if there's any more details that I want to cover here. I think we're going to get really, really deep into skill development, especially, and this is going to be the focus of the next couple of sessions, is like, let's actually make skills that do the things we want. Not just, oh, cool, Eliza's talking chatbot, but I don't know, visit, go summarize what happened on Discord for me today. Or go check my email, delete all the spam. I don't know, you can imagine all kinds of crazy skills that can come in here. And so, and maybe, or compound skills, like, a virtual assistant might have the skill of managing my calendar, but that might actually be a collection of skills, like, get the events for the range date, for today from my calendar, add an event to my calendar, delete an event. Those could all be different skills. And so we're going to work on skill development and skill testing as like a really big focus for the next kind of part of our academy sessions. But the key here is that you can start to make subspells and chain the subspells together. We're going to try and make better debug tools, because one of the things I struggle with is the complexity of how do I test these well. So don't worry, we're going to be working on all of that stuff. But just so you know, this is kind of our root graph, and we can, this used to be like 5 times more nodes. Now it's many less because we've consolidated them all into these subspells. And then if I wanted to just send you like my reflection subspell, I could just export it, send it to you, and then you could go and import it and just swap out which reference spell is here, and you can like upgrade your graph that way, and we can share skills and graphs and all that stuff this way. So the cool thing about skills is, since they don't have to be referenced, if you sent me a skill, like I have this plan skill, and you exported it, awesome. I could just go file import, grab your plan spell. I already have one, but now I have 2. And now I have your planning skill. Or maybe I have your upgraded planning skill, so I'll actually delete mine and then rename it to plan. And there you go. Now the last thing I would need to add that skill would also be, I have to go and add the documents here. I have to add some skill documents so that it can identify and find it. And those could be stories. And each skill can actually have a bunch of stories. For the skill of I should respond to the user, it's like, I should let the user know. I should respond to the user with the information they need. I should update the user on what I'm doing right now. And those could all tie back to the respond skill. I should figure out what I'm doing today. That could be a different way to describe the plan skill. And those each have different embeddings. And that way you can create clusters of embeddings, and they all map to the same end skill. But it creates a way to dynamically route between all of these different skills without having to have like some crazy decision-making process. Maybe I'll get into this a bit more next time, because this is something we're working on, and probably is a little bit, still a little bit code-like, I feel like, and I want this to be more something that, y'all who don't code a lot would feel very comfortable with. That's kind of where we're going with this. But just so you kind of understand what's going on under the hood, is we have these stories to determine what the skills are, and then we have subspells, which we've made, which are like this plan spell, that we call from the skill node. Okay, so subspells and skills are very similar. The difference is that subspells reference the spell directly. Skills find the skill. You could even just put in the spell name with the name input, but we're using this find skill kind of submodule to do that. And otherwise, they kind of do the exact same thing. They just call a spell and send data into it. So, good deal. I think I've covered everything that I want to cover. I wanted to give you guys a demo, but the agent stuff is a little bit, wires are open right now, and I don't think I'm going to get the agent to run and show you on Discord. So apologies for that. But I think that hopefully this kind of gives you enough download and on how to use. I'd say don't worry too much about the tasks and spells yet. I'm sorry, tasks and skills yet. I'm trying to, we're trying to get you guys acclimated to that, but we'll be going to that in way, way more detail. The real takeaway from today is to understand how we can embed graphs within graphs. And so you can imagine like a Westworld style intelligence that's just like 8 levels of graphs. Like you have a PhD just working on like recalling memory and making sure it recalls the right memories and quality, and there's a balance of like, more recent memories versus old memories and more relevant versus, you could imagine like a whole thing for emotions, or a whole thing for how we feel about somebody or our relationship to somebody. And then those could just be like one thing you drag in here, and you have all of that functionality, like a whole PhD research, person's thesis compacted into this one thing you just get to use. And then hopefully, as we start to teach you guys this stuff and you start getting into it, we can start sharing our learnings with each other. And this modularity kind of allows the human neural network, us, who are building this stuff together, to share our graphs, not just for debugging or see how you did something, but to just be like, yo, I really like that part. Can you just give me that whole skill or subgraph? And you're like, yeah, sure, totally. Or I'll trade you for what you're working on. And the last part we're going to work on is actually being able to share subspells publicly, so that you'll be able to come in from a library of existing subspells and bring them in. And so if you're somebody who loves building, as I do, and making things for other people, you'll be able to work on these cool problems and then share them with the rest of the community really easily, just like with a couple, what we're going to do is add a public thing here or something like that. Probably you can go and you can edit and add a description and make your spells public. That's coming pretty soon. So what we're really, eventually here, you're not going to have to worry about most of the stuff on the side. We're going to kind of provide you with the template API for ELIZA, and then we'll be upgrading together as we go. So I hope that makes a lot of sense. And if you guys have any questions, please post them in the chat, and we'll get to it. All right, thank you so much. Have a good one.